derivatives, okay? And for derivatives, so we just need to learn where to use them, where and when to use them. Okay, so let's start. At this point of our lessons, it's all mixed together. Everything that we have learned for how many number of years in the past, today or starting now, we are going to apply them mixed. Okay, you might be applying graphing, the different graphical methods, equations of parabola, equations of lines, circles, all of those. Okay, so if you are still, if you forgot all of those topics, it's I would advise you to go over your notes and uh, and try to read up on those topics that I have just mentioned. Okay, so first application of your derivatives is now what is for rate of change, okay, tangents and normals, okay. Rate of change, tangents and normals. Okay, so rate of change is just a fancy name for speed. Okay, when an object is moving, then there is a change. So how fast is it changing? That means it is a rate of change. Okay, so in other words, this is what just like when we try to recall our topics when we were in SMP. Remember this graph? I know that you still remember this. Okay, cyclist. Okay, remember this graph? There's a guy who is riding his bicycle. This is now in the distance, this in kilometers, and this is in time in hours. So it starts off at 8 o'clock, and then let's just make a basic one, 9 o'clock, and then let's say that this is now 10 and 20. So from point A to point B. So basic question. How far did he travel from A to B? How far did he travel from A to B?
20 kilometers.
20 kilometers. How long did it take him to travel that distance?
1 hour.
1 hour.
1 hour, okay, which means that given this information or data that we have here, we can now find its speed. How fast is he moving?
20 kilometer per hour.
Correct. Speed is equivalent to just using your, what's that, distance, speed, DRT, right? Distance, rate times time. This is now your basic formula, SMP1. And we are actually looking for the rate or the speed. Speed is equivalent to rate. So this is now equal to 20 kilometers per hour. Okay, so speed is actually r, which is now your rate. Okay, clear? So in other words, rate is how fast is the distance changing. Okay, so rate of change. That's the reason why we have rate of change. However, this one can also be translated to your rectangular coordinate system, okay, meaning your Cartesian plane. What is this? If we imagine that this is the Cartesian plane, okay, and we have a line, what will be the gradient? Okay, m. What will be the gradient? Your m is equal to delta y per delta x, correct? That's the change in y here. That will be your delta y going up here. Oops, let's do green. That's your delta y. And then that's your delta x. Delta y, delta x. So what will be the gradient? M is equal to what? Anyone?
2, yeah, teacher.
2?
2.
Why 2? It will be 20 per 1. Or just simply 20, correct? Yes?
Yes.
Yes, okay. Meaning now that your gradient corresponds in real world situations as your speed or your rate. Your gradient m is a rate. Are we clear on this? Yes? Yeah? Delta y per delta x, which is now same. That is now distance divided by time. So your gradient m is equal to the rate or your speed. So now let's move on a little bit further. If I have here a person, let's name him person, and then he is going to throw a stone in air like that. Okay, so the stone is going to travel along this line, going there until it reaches this spot. Okay, now, as the stone is moving along the air, then that means it has motion. It has movement, correct? Yes?
Yeah.
Yes.
Yes. When something is moving, then it must have speed. Correct?
Yes.
And if something have a speed, then that means it has a gradient. Can you follow the logic? A stone is moving, then that means it has a speed. And if it has a speed, then it has a gradient. Correct? Yes. So where can we find the gradient at this point? We learned about it before.
Using a tangent.
How do, using a tangent line, very good. Okay, so if you draw a tangent through that point, okay, at that particular point, this is now your tangent. And if you're going to get the gradient, if you find the gradient of this tangent, then if you have a gradient, then you can find the speed. So it's just, what's this? Vice versa, right? If there is a speed, then there is a gradient. If you can find a tangent, then you can find the speed. Can you see the logic? Can you realize the logic here? Correct? Yes? And what is now gradient?
Yeah.
Your gradient is delta y per delta x. Or this one is actually dy delta y, as we have learned before, dx. And dy dx is actually your derivative, right? So as long as you can find your function, if you get the function of this curve, and then you get the derivative of this function, dy dx, which is now delta y over delta x, then that is now your gradient. Now that you find your gradient, you can now find your speed. Done. That's the plan anyway. So, you understand where this is all coming from?
Yes.
Yes, okay. So we have discussed about rate of change, which is the same thing as the speed. We have a tangent that let us just review. What's a tangent again? Define a tangent. Tangent is?
It's a line that crosses through the points
Line
of the locus of the
that
parabola.
parabola only?
Any curve, I think.
That, yeah, any curve, correct. It not only passes, a line that touches the curve at how many points?
Exactly 1 point.
Okay, at only 1 point, okay? And how do we call that point?
Normal.
No,
Tangent point.
Tangent point.
point of tangency, okay, which is called the point of tangency. Okay, so that means this is now your PT, or your point of tangency, while this is your tangent. Now, there is another word here, which is now a normal. What's a normal? Not a tangent.
Is a line perpendicular to the tangent,
At where?
90 degrees.
90 degrees where?
In the
Passing
point of tangency.
point.
Correct. Okay, so a normal line is now a line perpendicular to the tangent at the point of tangency. Okay, so if I'm going to draw that, this is something like that. This is supposed to be at 90 degrees. This line now is called your normal line. Okay, so we are done with definition of terms. So you now know what is a rate of change, which is in basic terms is just speed. Okay, how fast it is. Okay, and then it is now going to be defined by the gradient of a tangent if you have a curve. Okay. Next, a normal, on the other hand, is a line that is 90 degree to the tangent that is now passing through the point of tangency. Now, take note, if this is applicable in a lot of ways in physics. Number one is projectile motion. Here, this is a projectile. When something is thrown at an angle up above the air, that's a projectile, okay? Free fall is just dropping an object straight down, okay? No initial velocity or something like that. So a projectile, on the other hand, is there is an initial velocity that is now projected at an angle, okay? Now, aside from that, there is also rotational motion. Rotational motion like in gears or wheels, of a wheel of a bicycle. So when you have a bicycle turning at an axis or an axle like this, okay, it's turning, at this point, if you get a tangent line over here and get its gradient, then you can now find how fast is the wheel moving, okay? And if you are now going to use a normal line, you can now find the equation for the radius or diameter of the wheel. So these are all very important concepts, so that if Teacher Jory will ask, what will be the radius of the wheel that is now moving around this speed, okay, or what's the diameter, you can just use this one, this concept, and then get the distance formula or whatever that you need in order to find this, okay? So anyway, these are just an overview of the things that we will be doing for this semester. Okay, any questions for now? No questions? Okay, so the things that you need here are, number one, you need to recall your graphing skills. Okay, graphing for linear, quadratic, cubic, minimum. Okay, that's the minimum requirement. Number two, your equations of a line. How to get an equation of a line, how to get an equation of parabola. Okay, those stuff. And what else? Maybe distance formula and midpoint formula. Properties of gradient as well, because we are again going back to gradients like this. Okay, so that's it for the brief introduction. Let's go straight to problem solving. Okay, first problem to solve. Let's do this. Okay, number one. Find the equation of the tangent to a curve y equal to the square root of 2x plus 1 at the point A, 4, 3. Okay. And after doing that, A, let's label that as A, B. If the tangent cuts Okay, so there we have it. Find the equation of a tangent to a curve y equal to square root of 2x plus 1 at point A, which is now at 4, 3. If the tangent cuts the x-axis as B at point B, how long is AB? Okay, with that, what's your plan on solving it? Anyone? What's the plan?
Graph.
Graph, very good. Okay, you can start by graphing. Okay, so at least to help you visualize what you are doing, let's have a graph. Okay, for this one, you do not need an actual accurate graph, at least something to visualize with. Okay, so I have the y-axis over here. I have the x-axis over here. That's your x and the y. Okay, I have y equal to square root of 2x plus 1. Okay, so let's use intercept method. I know that it's passing through this point, right? Because we have a tangent and it's passing through here. So let's start with that. That is now 1, 2, 3, 4. And then 1, 2, 3. So I know that it is passing, the graph is passing here at point A. That's point A. Okay, let's do the intercept method. When x is 0, what will we get?
1.
1.
Y is 1.
Okay, when x is 0, y is 1. So x is 0, y is 1. So it's moved there. How about the other one? When y is 0, x is what? Come on. Oh my gosh. Still sleeping, ah.
Negative half.
Negative 1/2. So we started with let given y equal to square root of 2x plus 1, let x equal to 0, we get y equal to 1. So that's your first point. I need to write everything that is now 0 and 1. So let intercept method, let y equal to 0, we will now get, when that is now 0, 0 is equal to square root of 2x plus 1. You can just evaluate this one and you can get x is equal to negative 1/2. So your point here is negative 1/2 and 0. Where is that? Here, correct? Yes? Which means now that by imagination, the graph should be moving from here going there. Okay. Okay. So now our task is to find the equation of the tangent of this curve. This is now y equal to 2x plus 1 at point 4. So we are expecting a tangent to be found there at this point. So what is the equation of this? We have the diagram. Next step is what? Come on, think. Do not
Gradient.
wait for me.
Find gradient.
Find the gradient of the tangent. How?
Find the equation of the tangent line. Then
How to find the equation of the tangent line? Since we have a line, we have three options to choose from. We have the point-intercept formula, two-point formula, point-slope formula. So which one will we use?
the
Slope-intercept, y equal to mx plus c.
maybe.
Can I use this?
Yeah.
Yes. Are you sure? What is c?
C is
Come on, guys, what is
the
c here?
y-intercept.
Y-intercept. Do we have a y-intercept?
Yes.
What is the y-intercept now?
we
Y-intercept of the line,
No.
not the
We
curve.
don't know.
We don't know. So basically, no, we cannot use that.
I
Two-point
think
formula.
two-point.
Two-point
no.
formula. We have 1 point. Give me a second point.
The one with two equation one.
Two equation one?
Apalah namanya?
Point slope formula.
Maybe
You cannot use two-point formula because you only have 1 point, right? So the last one that we can use is the point slope formula, the y minus y1 equal to m times x minus x1. For this one, I have x1 and y1, which is this coordinate here, 4, 3. And we just need a slope, gradient. So where can we find the gradient? See, remember, you see what I did here? You see what I did? You saw what I did, how to determine which formula to use?
Yes.
Okay, so now that I know that I have y1 and x1, I just need to find the gradient. And the gradient can be, again, from
On
what
by
we said a while ago,
deriving the equation.
derivatives, correct. So m, since m is equal to dy dx of the function f of x, so we have our function over here, right? So all we need to do now is get dy dx of this one, d dx of square root of 2x plus 1. Okay, so are you awake now? How to solve this?
I forgot what's the name.
Chain rule.
Yeah.
Chain rule, very good. Okay, using the chain rule, we let
Let
u
u
equal to 2x plus 1. And then we have here what? du. du is what?
2.
2 dx.
Oh yeah,
2 dx. Meaning our dx is du over 2. dx is du over 2. Sorry, small. Can you see it?
Yes.
du over 2. So finishing it up, that will now give us, substituting, that will now give us 1/2 u 1/2 u raised to 1/2, am I correct? du.
Not negative. Raised-
Yeah, it should be
raised to
negative 1/2, right?
Raised to negative.
Because 1/2 minus 1 equals negative 1/2.
Kurang. There's no du. Wait, I'm just substituting it. Maybe I am the one who is asleep. 1/2 u raised to 1/2 du. Correct? Then if we get the derivative, am I correct? No.
Oh, yeah, correct, teacher. Yeah, correct.
This one becomes u, but this is going to be raised to 1/2. Then the dx is going to become du over 2. Okay, so that's 1/2 du, u raised to 1/2. Okay, getting the derivative, it will give us what? Wait, tadasala. Wait.
Uh,
Something is wrong.
chain rule is the one with dy over du times du over dx. Right?
Okay,
So we
this is
let
going
u
to
and
be,
y.
this one should become
2x times half u raised to negative 1/2. Is it?
u raised to negative 1/2. Then that's 1/2 times 2. Am I correct?
Yeah, should be.
Yeah, okay. So after this one, we will now get this and this will cancel. So we will now get u raised to 1/2 or negative 1/2. And then this is going to give us what? Returning it back to the original. So it is going to be 2x plus 1 raised to negative 1/2. Okay, done. 2x plus 1 raised to negative 1/2, and this is our gradient. Okay, so dy dx. dy dx. But take note, dy dx is actually your gradient. Okay, are we clear on this? dy dx is actually your gradient. And what you have here, what you have solved here, this is now called your gradient function. Your gradient function is a formula or a function that can solve the gradient at any point of the curve. Okay, even if I will put a point here, I can just use that same formula, this formula, to get the gradient of the tangent at this point. Even if I move it to the next one over here, that's the same thing. That means you're drawing a tangent there, and you can still use this formula in order to get the gradient at this point. All you need to do is to substitute its x in this position. Okay, meaning what will now be the gradient at 4, 3? Meaning we just need to evaluate this one, dy dx at x equal to 4. Okay, so that will now be, I will erase this part over here. Okay, we have 5 more minutes. I hope we can finish this problem. Okay, so continuing it, that is now going to give us dy dx two x plus 1 raised to negative 1/2, where x is at 4 over here, this one. Okay, clear? So how much do you get here? Just substitute.
Gradient is equal to 1 over 3.
That is now 2 times 4 plus 1 raised to negative 1/2. So dy dx, or gradient, is equal to 1 per 2? Is that 1 per 2?
1 per 3.
1 per 3. Okay. So now that we have the gradient, we can now start solving for letter A over here. What will be the equation of this tangent? We can now use this formula that we have there in front. That will now be y minus y1, which is now 3, is equal to the gradient, that is now 1/3. Next will be x minus x1, which is now going to be 4. We multiply this together. We multiply all of it by 3 to remove the fraction, leaving us now with 3y minus 9 equal to x minus 4. And that will now give us a final equation. Equation of the tangent is now going to give us what? X minus 3y plus 5 equal to 0. Yes?
Yes.
Okay. And the last one, letter B. If the tangent, okay, if the tangent is extended, it will actually meet the x-axis at a certain point over here. And that is now going to be point B. What will that point be? Where is the coordinate of that point B? How will you solve that?
Using the intercept slope.
Okay, we use this equation of the tangent and let what?
Let y become 0.
Y equal to 0. And that is now 0. X is equal to negative 5. Okay, meaning this is at 0. Oh, sorry, negative 5, 0. Negative 5, 0. Now that we have that, last question, how long is segment AB? So how long is this? Using what?
Distance formula.
Distance formula. So D is equal to the square root of y2 minus y1. That is now, let's say, 3 minus 0 squared plus x2, 4 minus negative 5. 4 plus 5 squared. So how long is the distance between the 2 points? $20.80 81 plus 9.
Square root of 90.
So, square root of 90 in decimal?
It's 9.49.
9.49. Okay, done. So this is now the type of questions you will be answering for this semester. You can also start solving for the normal if you want. What is the equation of the normal? That will be your homework. Okay? What's the equation of the normal for this problem? Okay, that's it. We have less than a minute to go. Goodbye, everyone.
Goodbye and thank you, teacher.
Goodbye and thank you, teacher.
Goodbye, thank you, teacher.
Well, the teacher.
Sure.